When you first learn about speed and time, you tend to learn the formula speed equals distance over time. And you can rearrange this to distance is speed times time. However, this is only true when the speed is constant, which is not the case here. So why have I brought it up? Well, if I was to have a constant speed and draw my graph, it would look like this. And in fact, the distance would be speed times time. It would be the area of this rectangle. D is the area under the curve. And in fact, that it can be applied to any speed time graph. So that's just something that you need to know. Now we can do this, it's very tough to do this exactly because of the curved line. You can sort of estimate it by splitting up and using trapeziums and so forth. But it's only 2 marks, so I'm going to use a slightly simpler approach. I'm just going to count the squares. Okay, let's give it a go. So every time I draw a square, that's going to be 1. That wasn't a very good. Let's try that again. 2. This looks like it's 3. Then we've got 4, 5, got a bit left over there. 6. I think this and this can combine to give 7. We'll call this 8, and I'll call this 9. Okay, so I'm just going to do a little tally. So far, that's 9. Let's keep going. Then I've got this is 1, 2. Let's call this 3, 4, 5. I think I'm pushing it a bit with this bit. Let's call this 6, but discount that bit. Let's call this 7, but discount that bit. Let's call this 8, but discount that bit, and then I've maybe got a half in there. So I can just tally these bits: 1, 2, 3, 4, 5, 6, 7, 8 and a half. Okay, so overall, I've got about 17.5 meters. Now, what's the exact answer? I don't actually know. I do know that any answer in the range 15 to 22 is accepted. So we're that's not bad, is it? You know, the midpoint's 18.5, isn't it? But I've done it pretty accurately, and that's enough. So the main thing is to know that it's the area under the graph, and then just use a careful but simple approach to be able to work out the distance.